Hello, good morning, students. Am I audible to all of you? Is my computer screen is visible to all of you? Welcome to the video lecture series of microprocessors and microcontrollers theory. Students are replying, yes sir, you are audible and visible. So, in this lecture, this is our last lecture regarding the microprocessors and microcontrollers theory. We are discussing today chapter 4 of module 8, which is popularly known as Brief Introduction to PIC Microcontroller, the IC number 74F877. This is our lecture number 1 regarding the PIC microcontroller. Let me repeat it for you that this is our last chapter regarding this last chapter and last module regarding the video lecture series of microprocessors and microcontrollers theory. First of all, we are about to discuss what is PIC 16F877. So we are observing that it is one of the most advanced microcontroller from Microchip Corporation. This controller is widely used for experimental and modern applications because of its low price, wide range of applications, high quality, and it will ease the availability. So naturally we can come to a conclusion. What is PIC 16F877? It is a advanced microcontroller. It is developed by which company? It is developed by Microchip Corporation. Why it is used? It is used for experimental and modern applications. What are the advantages of this microcontroller? The advantages of this microcontroller are: it is a low price microcontroller, it is used for wide range of applications, it is used for high quality of applications, and it will ease the availability of the microcontroller. So these are advantages of this PIC microcontroller. It is an ideal for applications such as machine control applications, measurement devices, study purpose, and so on. So the different applications of this particular microcontroller known as PIC 16F877 are machine control applications, measurement devices, study purpose, that means we can able to study this microcontroller to know the details, we can able to program in this microcontroller to run some microcontroller related programs, so that our programming, logical and analytical capability will be increased. The PIC 16F877 features all the components which modern microcontrollers normally have. The figure of PIC 16F877 chip is shown below. It is observed that PIC 16F877 features all the components which modern microcontroller normally have. First of all, we need to know which components all modern computer must have. All modern computer microcontroller must have a MPU or microprocessor unit, an internal memory, an external memory, and peripheral devices and input and output devices. Peripheral devices are analog to digital analog to digital converter, digital to analog converter, timer, counter, etc., and serial ports. Similarly, input devices are keyboard, LED or LCD display, and input devices are monitor, keyboard and mouse, and output devices are LED or LCD display and printer. So these components must be there in the microcontroller. This is a PCCCS502 chip. It looks like just an 8085 microprocessor or 8051 microcontroller chip, but it has some advanced capabilities. So we are now observing what are the features of PCCCS502 microcontroller. PCCCS502 series has more advanced and developed features when compared to its previous series. The important features of PCCCS502 is given below. We are about to discuss the general features, peripheral features, key features, analog features, special features. So let us discuss first the general features. First general feature is it is a high performance RISC CPU. What is RISC? Reduced instruction set computer. You know there are two types of computer in terms of categorization of instruction set: reduced instruction set computer and complex instruction set computer. So it is a RISC CPU. CPU stands for Central Processing Unit. We know that microprocessor contains an MPU, and that MPU contains a Central Processing Unit, which is in combination of the arithmetic logical unit, control unit, and register array. Only 35 single word instructions. Only 35 simple word instructions. So how many instructions are available? Only 35 simple word instructions are available in this microcontroller. All single cycles instructions except for program branches, which are 2 cycle. Most of the instructions are basically single cycle instructions. That means they can be finished within 4 or 3 T state, except branch instruction, which is finished by 7 or 10 T states. Operating speed. It is very important to note the operating speed of any microprocessor or microcontroller. The operating speed decides the functionality and capability of any microcontroller. We are observing that the operating speed of PCCCS502 is 200 megahertz. So if the clock input or clock frequency increases, naturally as because tau is equal to 1 by f, so naturally the clock period decreases. If the clock period decreases, then less amount of time is required to complete an operation. So as you see, instruction cycle is of 200 nanosecond, which is the time to complete an instruction. Maximum time to complete an instruction. Up to 368 cross 8 bit of RAM data memory is available in this microcontroller. 368 means there are 368 locations are there in the data memory RAM. 8 bit means there are 8 bits of data can be stored in each memory locations. I repeat, 368 cross 8 means there are 368 locations and each locations is capable of storing 8 bit of data in the RAM. Next, data memory EEPROM. EEPROM is normally holds the necessary programs that is required to run the microcontroller. EEPROM stands for electrically erasable programmable ROM. ROM stands for read-only memory. So naturally, EEPROM basically stores all the necessary programs which are required to start the microcontroller or which are required to execute the program or execute the subroutine or execute the interrupt. EEPROM is part of data memory. RAM is also part of data memory. RAM stands for random access memory. RAM can able to store the data. That means we can perform read and write operation, whereas EEPROM we mostly perform reading operation. Programs are preloaded in EEPROM. We perform reading operations from them. We have 8K cross 14 of flash memory. 8K, that means there are 8K or 8 kilobyte of locations available. 8,000 basically locations are available. 8,000 over 8,000 locations are available, and each location is capable of storing 14 bits of data. This is the size of the flash memory. Flash memory normally works as normal pen drive or external hard disks or some secondary memory. So it has a concept of data memory such as RAM or EEPROM, and it has also the concept of flash memory. Pinout compatible to PIC 16C7 4B, PIC 16C76, PIC 16C77. So these are various versions of this microcontroller series. Next general feature is 8-level deep hardware stack, interrupt capability. So there are 14 sources from the interrupt can come. So any interrupting device can request the microcontroller with the help of 14 different sources, and microcontroller will select one of them at a point of time with the help of proper programming logic, and that particular interrupt will be accepted. Rest of the interrupt will be rejected. So interrupt capability is one of the most important feature of this microcontroller. Different types of addressing modes are supported in this microcontroller, such as direct addressing mode. Direct addressing mode may be of two types: memory direct, register direct. Whenever we are retrieving a data from a register directly, then it is register direct. When we are retrieving an operand from a memory address, then it is memory direct. Indirect addressing mode is of two types. Whenever we are retrieving an operand via a register, then it is register indirect. Whenever we are retrieving an operand from a memory address via another memory address, then it is memory indirect. Then relative addressing mode may be PC relative, base address relative, index register relative, etc. Power on reset is feature is applicable. That means whenever we power off the microcontroller, all the data stored in the data memory, especially in RAM, will be demolished, and similarly all the registers array will be emptied. Whenever we power on, once again it will start and it will continue to load the data once again. Power up timer, PWRT. PWR stands for power and T for timer. So power up timer and oscillator startup timer, we are using these two types of timer for timing and control generating signals. Timer also decides that how many T states are required to finish off a particular instruction, when to start an clock cycle and when to end an clock cycle. Low power high speed CMOS flash or EEPROM is required. CMOS is basically a complementary MOSFET circuit which is required to produce the flash memory or EEPROM data memory. Flash memory is considered to be the secondary memory and EEPROM is considered to be the main memory. EEPROM is storing the prerequisite programs and flash memory is storing the temporary permanent data which is to be stored in the secondary memory, just like an hard disk. It is a fully static design. That means there is no configuration change after every power on and power off. That means it cannot be changed. The design of the system is absolutely static. It cannot be changed due to time, and so it is not a dynamic operation. Wide operating voltage range. We are observing the voltage range is from 2.0 to 5.56 volt. Okay, so in that particular voltage, this particular microcontroller will work. High shrink and source current. Amount of current supported by this microcontroller is 25 milliampere. Commercial, industrial and extended temperature ranges. Whenever this microcontroller is used for commercial purposes, it supports different range of temperature. Whenever it serves the industrial purpose, it supports different range of temperature. And whenever it is used for extended purposes, it supports different range of computers. Low power consumption. The last general feature is low power consumption. we are observing that less than 0.6 milliampere is a typical the power current supply that is needed. 3 to 4 megahertz, that is the frequency required, and 20 microampere is typical needed, and 3 volt to 32 microhertz is required, and less than 1 ampere is typically required in standby mode. So these are the general features of this particular microcontroller. Now let us talk about the peripheral features. Before moving to peripheral features, let me ask your questions. Let me ask some questions. Let me take some questions from your side. If you have any question, please write it down in the chat box, or else we can continue with the peripheral features. If you have any question related to general feature, if you have any question related to the introduction of PIC microcontroller, then you can ask. One question come, sir, would industrial system prefer to use PIC or PLC in SCADA system, or depends on the user purpose? Absolutely depends on the user purpose, okay, that which systems is basically used. But PIC microcontroller is more popular. PIC microcontroller is more popular than PLC, no doubt about that, but it absolutely depends on the industry purpose, why it is used, which functions should be there. Depend on that, it is totally depends on the user purpose. Any more question from your side, or else I can continue the peripheral features. I hope there is no question from your side. So let us continue with the peripheral features. We are observing that if you talk about the peripheral features, first of all we need to know what are peripherals. Peripherals are timer, different types of modules, analog to digital converter, serial port, parallel port, synchronous asynchronous receiver transmitter, etc. So microcontroller PIC use basically 3 major types of timer. First is timer 0. Timer 0 is an 8-bit timer or counter with prescaler. Timer 1. Timer 1 is a 16-bit timer or counter with prescaler. Timer 2 is a 8-bit timer or counter with 8-bit period register with prescaler and postscaler. Okay. So it is a types of scalar functioning. It can do scalar functioning, but some of them, timer 2 is prescaler and postscalar both, but timer 0 and timer 1 is mostly prescaler. That means previously we have to scale it down. Okay, we have to scale timer 0 and timer 1 previously before the operation, and timer 2 can be either prescaler and postscaler. That means after the operation and before the operation we can scale this device. Timer 0 size is 8-bit, timer 1 size is 16-bit, timer 2 size is 8-bit. Why timer or counter is written in the slash? Because both timing and counting operation is basically done by this unit. Timing operations such as example is calculating the clock period. That is an operation of the timer. Calculating the clock period, it is an operation of the timer. That means to complete an instruction, how much time is required, that is basically calculated by the timer. Counter. Counter is used for loop. So counter is used in loop, and counter is basically counting and required during the loop to understand when to start the loop, when to stop the loop, and how much the loop has iterated. Next, it has several modules. 2 capture modules, 1 compare module, and 1 pulse width module. Capture module naturally capture different things such as display capture. Compare module can compare basically the different data. Pulse width module can generate the pulse and display the clock cycles, or by means of pulse width, by means of pulse display or pulse width. We have an analog to digital converter which is multi-channel and its size is 10 bit. That means each channel can able to take 10 bit of digital data converted by the analog system, and each channel can able to transport 10 bit of digital binary data, and that to be converted to analog signal. So analog to digital and digital to analog signals are converted with the help of analog to digital signal. Synchronous serial port is used. Serial port performs serial communication. That means 1 bit is transmitted at a point of time. Synchronous, that means both source and receiver are sync with a common clock. I repeat, synchronous means both source and receiver are synchronized with the help of a common clock. With SPI, the master code, and with I2C, the master or slave. So one port is basically acting as a master and another port is acting as a slave. Okay. Universal synchronous asynchronous receiver transmitter, or USART, is used, which we have already used in 8085. In 8085, the IC number for USART is 8251. Here we are also using this as a peripheral device. It can detect 9 bit of binary address. Parallel slave port. Parallel slave port is denoted by the abbreviation PSP. Parallel slave port can perform parallel data transmission operation. It is 8 bit wide. That means the width of this port is 8 bit with external WRD line for reading operation, WR for writing operation, and CS bar for control operation or chip select operations. I repeat, the parallel slave port can perform reading operation, writing operation and chip select operation. So these operations can be performed with some external devices with the help of this particular port known as PSP. Brownout circuitry for brownout reset is used, which is used to reset the whole microcontroller system, just as reset pin in 8085 microcontroller processor. Key features. What are the key features? Maximum operating frequency is 20 megahertz. We know that if frequency increases, then clock period or tau decreases, because tau is equal to 1 by frequency. If clock period decreases, then less amount of time will be required to complete a job. Flash program memory. 14-bit words are basically can be stored in the flash program memory, which is typically stores the necessary program to compute any kind of job in the microcontroller. 8 KB size is there. That means total size of this memory is 8 KB. That means 8 KB different locations are there, and each location is capable of storing 14 bits of binary data or words. I repeat, the flash program memory size is basically holds 8 KB different slots, and each slot is capable of storing 14 bits of different words. Data memory. The data memory has 368 slots, and each slot is capable of storing 8 bits of data. EEPROM. EEPROM data memory holds basically the programs, instructions, opcodes. There are 256 slots where this program, opcode, instructions can be stored. It has 5 input or output ports. With the help of this input and output ports, we can take input from the input devices such as external keyboard and mouse. LED or LCD display can be considered as an output device. 3 timers are used here: timer 0, timer 1 and timer 2. Two CCP modules are basically used. That means capture modules are used. 2 serial communication ports are used. One is MSSP and another one is universal synchronous asynchronous receiver transmitter. These 2 communication ports are used. Parallel slave port is used for parallel communication, and 10-bit analog to digital module is used with 8 channels. So these are considered to be the key features. Analog features. Microcontroller is capable of converting analog signal to digital and digital signal to analog with the help of the analog to digital converter. It is using up to 8 channel analog to digital converter. That means analog to digital converter has 8 different channels. With each channel they can able to take input from outside world, and they can be converted into digital data. Similarly, if we are using digital to analog converter, then it can capable of converting the digital signal to analog. Each channel is supplying 10 bit of data. Brown out reset function is used, which is used to reset the register array and the necessary system components so that we can refresh our system, so that we can start our system from the beginning. from the initial point. Analog comparator module is required in order to compare different data. Serial special features. 1000000 times erase or write cycle enhanced memory. That means this particular enhanced memory can erase its locations 1000000 times and also can write the data into it. It has an EEPROM memory which can able to perform erase and write operations up to 1000000 time. So we can observe that 1000000 time we can erase the EEPROM memory and we can store the new data, and 1000000 times we can able to write the data in the erased memory present in the EEPROM. Self-programmable under software control. So we can able to program the memory. Such, for example, EEPROM, which is electrically erasable programmable memory, as the name suggests, it is programmable. So with the help of the special software, we can able to program this memory, and it is self-programmable. In circuit serial programming, in circuit debugging capabilities. Microcontroller, this particular PIC microcontroller contains some circuitry which is used for serial programming and which is used for debug purpose. Debugging to find out the error in the program or in the circuit or in the system. Serial program means we can able to write a program so that serial communication can be done. Next point, single 5 voltage DC power supply is used for circuits in serial programming. WDT with its own RC oscillator for reliable operation. RC oscillator is just like a crystal oscillator, and it will generate the frequency of the microcontroller. Next, programmable code protection. So if there is some predefined programmable code which is used to run the system, which is used to start the system, which is used to stop the system, which is used to reset the system, which will handle the interrupt, those types of programmable code must need to be protected, and that protection feature is also there in the PIC. Power saving sleeping mode. As we normally observe in our laptop, there is a sleep mode, there is a hibernating mode, so that the power can be saved. This is also available. Selectable oscillator options is also there. Whenever we need to generate more frequency, then we have lots of oscillator options through which we can able to generate more and more frequency. Whenever we require the less frequency, we can able to select the oscillator according to our purpose. Pin diagram. Before discussing pin diagram, let us take your question. What is display capture? Just like in a mobile phone, you have observed that there is a display capture or snapshot option. Okay, In lots of software such as OBS Studio, there is also a display capture option. That means whatever the programs you are running, whatever the operations you are running, you can able to capture it so that you can able to notice this later on. That is display capture. What is the difference between prescaler and postscaler? Prescaler means scale. We can scale the component previously before the operation, and postscaler means we can scale the component after the operation. That is prescaler and postscaler. I hope I make myself very clear. Prescaler means we can scale the component before the operation. Pre means before and post means after, and postscaler means we can scale our component after the operation. I think I have given the answer to all the questions. Without wasting time, we can discuss the pin diagram. PIC16F877 chip is available in different types of packages. You know that 8085 microprocessor pin is also available in 40 dual in package. According to the type of applications and uses, these packages are differentiated. The pin diagram of a PIC16F877 chip in different packages is shown in the figure below. This is the figure that we are observing. This is a 40 pin package, dual in package. This is a 40 pin TQFP package, and this is a 40 pin QFN package, where we are observing lots of pins such as VSS, VDD. These are power supply pins, okay, and many more. I am not discussing these pins in details because we have already learned 8085 and 8051 pin description. We have already learned 8086 pin description, so we can understand that what these pins are basically does. Input output ports. PIC16F877 have 5 basic input and output ports. They are usually denoted by port A, denoted by RA, port B denoted by RB, port C denoted by RC, and port D denoted by RD, and port E denoted by RE. If we look at the pin description, we can observe that, look at that, RB, RB5, RB4, RB7, RB6, RB3, RB2, RB1, RB0. So these are 8 different pins of port number B. Similarly, we are observing that there is RA0, RA1, RA2, RA3, RA4, RA5, RA6, RA5, and then we have in this these are basically pins there, and we have RE0, RE1, RE2 pins are there. OSC1 and OSC2 are stands for crystal oscillator circuitry pin. RC0, RC1, RC2, RC3 are pins related to port number C. RD0, RD1, RD2, RD3 are related to pins related to port number D. RC4, RC5, RC6, RC7, they are pins related to port number C. RD4, RD5, RD6, RD7, they are pins related to port number D. Port number D, port number C, they are basically, mostly they are basically bidirectional in nature. Port B is all the ports are bidirectional nature. Some of the ports are also perform dual purposes such as pin number 33, which is RB0/INT. INT stands for interrupt. INT stands for interrupt. There are lots of versions of the PIC microcontroller. You are observing that there are 3 versions. In 3 versions, there are 3 different types of pin configurations. So we can observe that there are 5 different ports: port A, port B, port C, port D. These ports are used for input-output interfacing. In this controller, port A is only 6 bits wide, RA0 to RA7. Port B, port C, port D are only 8 bits wide, RB0 to RB7, RC0 to RC7, RD0 to RD7. Port E has only 3 bit wide, RE0 to RE7. All these ports are bidirectional in nature. As you can see, all the ports are bidirectional. Port A is bidirectional, look at that. Port E is bidirectional. Port C is bidirectional. Port D bidirectional. Port C bidirectional, and port B also bidirectional. The direction of the port is controlled by using TRIS within bracket X register. TRIS register, if TRIX, if X is replaced by A, that means this register will control the direction of port A. If X is replaced by B, then this register is direction is controlled by port B's direction is controlled by TRIS B. Okay, setting TRIS X bit by 1 will set the corresponding port X bits of the input. Clearing TRIS X bit by 0, corresponding port X bit as output. If we want to set port A as input, just set TRIS A bit to logical 1, and if we want to set port B as output, just set port B bits to logical 0. So if we want port A to be as input port, we have to set the TRIS register. TRIS register, then we have to give A in terms of X, because X denote the port. X can be A, B, C, D, E. As because we are setting a port, so we are writing A in terms of X. If I place one logical value to every bits, then we can set TRIS A, and if I set 0, then it will be set as output. We are observing that port A is basically the 6 bit wide, RA0 to RA5. There is a mistake in there. This should be, it should be written RA0 to RA5. So there is a mistake. Port B, port C, port D is 8 bit wide. So it should be RB0, RB7, RC0, RC7, RD0, RC7. But port E is 3 bit wide, so RE0 to RE2. So we are observing that, look at that, there is exactly 3 pins for port E, RE0, RE1, RE2. So 3 pins are there for E. 6 pins is there for A, RA0, RA1, RA2, RA3, RA4, RA5. Whereas port C has 8 pins total. Look at that, PC7 to PC0. Okay, and RD0 to RD7. Similarly, RB0 to RB7. So port B, port C, and port D are 8 bits wide, and port E is 3 bit wide, and port A is 6 bit wide. Input output ports, analog input port, which are denoted by AN0 to AN7. These ports are used for interfacing analog input. TX and RX. TX for transmit the data, with the help of the universal synchronous asynchronous receiver transmitter peripheral component, and RX stands for receive data, which will receive the data from USART. SCK. These pins are used for giving synchronous serial clock input, and SCL. These pins are act as an output for both SPI and I2C mode for serial communication. DT stands for the data terminal. It is synchronous in nature. CK stands for synchronous clock input. SD0 stands for SPI data output. And SD1 stands for serial parallel interface data input. SDA is a pin which stands for serial data input and serial data output in I2C mode. CCP1 and CCP2, there are two capture and they are performing capture, compare and PWM or pulse width module operation. OSC1 stands for oscillator input, OSC2 stands for oscillator output. MCLR stands for master clear pin, BPP stands for programming voltage input, THB stands for test mode controlling high voltage pin, V reference stands for reference voltage which can be positive or negative, SS stands for select serial synchronous serial port, T0CK1 means timer 0 clock 1 input, and T1 SO stands for timer 1 oscillator output, and T1 OS1 stands for timer 1 oscillator input. T1 CK1 stands for clock input to timer 1. We are observing all these pins in our pin diagram. It is used for external interrupt signal, as it is used as external interrupt signal. RD is a control signal which is used to read the perform the read operation. CS is chip select operation. PSP0 to PSP7, these are parallel slip ports. There are total 8 parallel slip ports. VDD stands for V for naturally voltage, you all know. So it is a positive supply for logic and input pins. VSS stands for ground reference for logic and input output pins. So with this I am ending this lecture. If you have any question, you can ask. If you have any question, you can ask. Any question? Any question from your side? Aditi Ghosh writing no question sir. Waiting for the questions of the students. Shovik writing no question sir. Shreyoshi writing no question sir. Moinak writing no question sir. Okay then, thank you for your patience hearing. We are ending our session here. Next week we shall discuss 8051 microcontroller programming with the help of the simulator or trainer kit.